Top 10 Fraud Detection and Transaction Monitoring Agents, updated August 17, 2026. Fraud prevention is moving from isolated risk scores to end-to-end risk operations. Modern systems are expected to score a transaction in real time, connect it to related accounts and devices, investigate the surrounding activity, explain the decision, and recommend what should happen next. That workflow matters because a transaction model and an investigation agent solve different problems. Rules and machine learning models detect and score risk. Agents gather evidence, connect events, summarize cases, recommend actions, and sometimes automate low-risk dispositions. Unit 21 describes this distinction directly. A fraud agent should execute investigation tasks rather than merely display a score or summarize information already visible to an analyst. The strongest platforms therefore combine real-time rules and machine learning, behavioral and device intelligence, graph-based entity and transaction analysis, case investigation and evidence collection, explainable decisions and immutable audit trails, remediation recommendations, model drift and outcome monitoring. This article compares 10 leading platforms against those requirements, with particular attention to precision, recall, fraud capture uplift, chargeback outcomes, analyst productivity, privacy, latency, explainability, and model drift. Executive verdict: there is no universally best fraud detection agent. The right choice depends on whether the primary problem is card fraud, instant payments, account takeover, authorized push payment scams, money laundering, sanctions screening, or investigation capacity. For the full table, please open this article on AIAgentStore.ai. The most important conclusion is that agent maturity and detection quality are separate dimensions. A platform may have an impressive investigation copilot, but weak transaction-level recall. Another may have excellent fraud scoring, but limited autonomous casework. Buyers should evaluate the two layers separately. How fraud detection agents work. A practical fraud and transaction monitoring architecture has 4 layers. Real-time decisioning. This layer evaluates a payment before it settles. It typically combines deterministic rules, velocity checks, behavioral profiles, device and session signals, customer and counterparty risk, historical transaction patterns, network or consortium intelligence, supervised and unsupervised machine learning. The output is usually an approve, decline, hold, or review decision, accompanied by a risk score and reason codes. Graph and relationship analysis. Graph-based systems connect customers, accounts, cards, devices, internet addresses, telephone numbers, email addresses, merchants, beneficiaries, counterparties, transactions. This is especially useful for fraud rings, mule networks, synthetic identities, collusion, account takeover, and money movement through multiple accounts. However, graph analysis is not automatically graph reasoning. A visualization that shows connected entities is different from a model that evaluates multi-hop relationships, transaction sequences, and network behavior. The best systems produce evidence paths, such as, this beneficiary received funds from 7 recently opened accounts, all associated with 2 devices and 1 telephone number previously linked to confirmed fraud. Investigation agents. An investigation agent can retrieve transaction history, search linked entities, review prior alerts and dispositions, examine device and behavioral information, query external intelligence, identify related cases, build a timeline, summarize evidence, recommend a disposition, draft an internal case narrative, prepare a suspicious activity report. The agent should show the evidence supporting each conclusion. A fluent narrative without source records is not sufficient for a regulator or an experienced investigator. Remediation and feedback. The final layer recommends or executes actions, such as approve the transaction, request stronger customer authentication, place a temporary hold, decline the transaction, suspend an account, block a device or beneficiary, recall or return funds, contact the customer, escalate to a senior investigator, file a suspicious activity report, initiate enhanced due diligence, create or modify a rule, add linked entities to a watch list, monitor the customer more closely. High-risk actions should remain subject to policy controls and human approval. The agent should not have unrestricted authority to change rules, permanently close accounts, or file regulatory reports without governance. Important limitations of public benchmarks. Fraud vendors often publish impressive percentages, but these figures are rarely directly comparable. Public case studies may report a percentage change from an undisclosed baseline. fraud value captured rather than transaction-level recall, false positive reduction without false negative data, results from one payment rail, a short testing period, a customer-specific implementation, a selected fraud typology, a model operating alongside other controls. Most vendors do not publish a standardized confusion matrix containing transaction counts, fraud prevalence, precision, recall, false positive rate, false decline rate, chargeback outcomes, and confidence intervals. That means the rankings below are based on capability fit and public evidence, not on a claim that one vendor has definitively achieved the highest real-world precision or recall. Precision and recall for a fraud detector. Precision asks, of the transactions flagged as fraud, how many were actually fraudulent? Recall asks, of all fraudulent transactions, how many did the system capture? False positive rate measures legitimate activity incorrectly flagged or blocked. False negative rate measures fraud that passed through undetected. Because fraud is usually rare compared with legitimate activity, accuracy can be misleading. A recent study using the public European credit card dataset worked with 284,707 transactions and a fraud prevalence of only 0.173%, while enforcing chronological data splits to model temporal drift. A model can appear highly accurate while missing a commercially significant amount of fraud. Buyers should prioritize precision at the actual review rate, recall at the actual decline or intervention rate, fraud value capture, false declines, chargeback and dispute rates, approval and conversion rates, analyst workload, performance after labels mature, public evidence snapshot. The following figures are vendor-reported or customer case study results, unless otherwise noted. Not publicly disclosed means that the vendor does not publish a comparable precision and recall result for the full platform. For the full table, please open this article on AIAgentStore.ai. The top 10 fraud detection and transaction monitoring agents, Unit 21, best all-round agentic platform for fraud and financial crime. Unit 21 is one of the clearest examples of a platform designed around the complete detection to investigation workflow. Its system combines rules, behavioral signals, device intelligence, graph analysis, fraud consortium information, case management, and artificial intelligence agents. Its detection agent analyzes transactions and alerts in real time. Its investigation agent gathers evidence, identifies linked entities, summarizes risk, recommends actions, and creates case narratives. The platform also supports alert to case to suspicious activity report workflows with documented investigative steps. Where Unit 21 performs well. Strong fit for fintechs, payment firms, and financial institutions. Sub-250 millisecond real-time decisioning claims, rules, explainable machine learning, graph-based rules, and investigation agents in one environment. Shadow testing, historical validation, and sandbox deployment. Cross-channel monitoring across automated clearinghouse, wires, cards, instant payments, cryptocurrency, and account-to-account payments. Agent-generated evidence trails rather than only narrative summaries. Unit 21 also emphasizes that risk teams can see which variables contributed to a machine learning score and can use graph-based rules to expose hidden relationships. Benchmark assessment. Public materials report a 50% reduction in false positives and a 70% reduction in fraud loss in one customer-facing product example, but the company does not publish a standardized precision, recall, or chargeback benchmark across customers. Best choice for a growing financial technology company or payment institution that wants one platform for real-time scoring, investigations, graph analysis, and remediation workflows. Main risk. Buyers should verify whether the investigation agent is permitted to auto-close alerts, only recommend dispositions, or perform different actions by risk tier. Sardine. Best for device intelligence, fraud graphs, and digital commerce. Sardine combines device intelligence, behavioral analytics, machine learning, rules, network intelligence, graph analysis, and agentic fraud operations. It is particularly strong where fraud involves the customer journey before the transaction, including onboarding, login, account takeover, bots, synthetic identity, payment fraud, and scam behavior. Its graph capability connects users, devices, internet addresses, telephone numbers, email addresses, and transactions. Its agents include transaction monitoring, graph analysis, rule assistance, data analysis, open-source intelligence research, sanction screening, and suspicious activity report generation. Where Sardine performs well, device and behavioral intelligence, account takeover, and bot detection, cross-channel identity and transaction analysis, merchant and digital commerce fraud, graph-based fraud ring investigations, rules created from natural language descriptions, automated dispute and chargeback workflows, bank payment risk before submission and settlement. Sardine reports several customer-specific outcomes, including 95% precision in one onboarding decision use case, a 70% reduction in card-related chargeback losses in one banking deployment, and a 0.0003% chargeback rate in that same case. It also reports that one deployment resolved 55% of alerts in approximately 30 seconds. Benchmark assessment. Sardine's chargeback figures are commercially useful, but chargeback rate is not the same as recall. A lower chargeback rate may result from better detection, more customer authentication, tighter approval policies, different merchant mix, or a shift in liability. Best choice for digital banks, payment companies, marketplaces, cryptocurrency platforms, and merchants that need identity, device, graph, and transaction intelligence together. Main risk: require a rail-by-rail benchmark. Results from onboarding or card fraud should not be assumed to apply to automated clearinghouse payments, authorized push payment scams, or anti-money laundering monitoring. Best for large-scale payment fraud decisioning. FeedZai is a mature enterprise fraud platform focused on high-volume, real-time payment decisions. Its RiskOps platform combines identity, fraud, and anti-money laundering controls, while its network products add collective intelligence without requiring institutions to share raw personally identifiable information. FeedZai IQ states that raw data stays in the institution's environment, while anonymized risk signals and aggregated patterns are exchanged across the network. FeedZai reports 4 times more fraud detected, 50% fewer alerts than rules-based approaches, and a 27% improvement in payment acceptance for users of its network intelligence product. Where FeedZai performs well: large banks, payment processors, and card networks, real-time omnichannel payment scoring, rules and machine learning used together, network intelligence and graph visualization, explainable reason codes, natural language rule creation, case investigation, and analyst workflow, privacy-conscious consortium intelligence, high-volume model deployment. FeedZai reports that one large North American bank achieved a 75% average value detection rate at a 0.1% intervention rate, alongside a 12-to-1 false positive detection rate. It also reports a 73% reduction in false positives and 62% more fraud detected than a previous solution in other enterprise examples. FeedZai's genome investigation capability uses visual relationships among customers, cards, transactions, and other entities. One customer case study reported that an investigation that previously took half a day could be completed in approximately 10 minutes, with a 15% increase in fraud detection on specific alerts. FeedZai has also published research on automatic model monitoring for streaming fraud data. Its monitoring approach is designed to identify changes before labels become available and produce explanations for the likely cause of drift. The research was evaluated across 5 real-world fraud datasets totaling more than 22 million online transactions. Best choice for large banks, processors, and payment networks that need mature real-time decisioning, broad payment coverage, and sophisticated model operations. Main risk: FeedZai has a wide product portfolio. Buyers should test the exact combination of fraud scoring, investigation automation, network intelligence, and anti-money laundering functionality being purchased. Comply Advantage Mesh, best for automated transaction monitoring remediation. Comply Advantage Mesh is strongest in anti-money laundering, transaction monitoring, customer screening, sanction screening, and risk intelligence. Its recent platform strategy places agentic workflows inside a unified case management system. The platform states that its decision chain can resolve 65 to 85% of false positive alerts through a combination of risk scoring, artificial intelligence agents, and analysts. It also reports more than 100 transactions per second with sub-second response times and more than 3.5 billion daily messages processed across the platform. Where Comply Advantage performs well: rules and advanced machine learning working together, transaction monitoring and payment screening, natural language rule creation, graph and clustering patterns, automated alert remediation, case management and audit trails, suspicious activity report preparation, risk intelligence based on sanctions, politically exposed persons, adverse media, and behavioral signals, regional data segregation, and enterprise security controls. Comply Advantage reports that Pay Near Me reduced analyst time spent on transaction monitoring by approximately 50%. Paytron reported a 20% reduction in false positives and a 75% reduction in post-transaction queries. Its public platform materials claim up to 82% false positive reduction, but these numbers should be treated as vendor-reported outcomes rather than an independent benchmark. Privacy and governance. Comply Advantage states that Mesh supports encryption at rest and in transit, geographic data segregation, role-based permissions, single sign-on, International Organization for Standardization 2701, Service Organization Control 2, and General Data Protection Regulation compliant data handling. These are useful controls, but buyers still need to review the contract, subprocessors, retention periods, and model training terms. Best choice for payment companies and financial institutions whose primary bottleneck is anti-money laundering alert volume and remediation rather than card authorization latency. Main risk. Validate fraud-specific recalls separately from anti-money laundering alert resolution performance. NICE Actimize. Best for large bank investigations and regulatory reporting. NICE Actimize is an enterprise financial crime platform covering fraud prevention, anti-money laundering, sanctions, suspicious activity reporting, case management, and investigation workflows. Its platform reports that it monitors more than 5 billion transactions per day and uses millisecond-level fraud detection. It also offers network analytics, typology-based risk scoring, integrated investigations, and generative artificial intelligence for case summaries and suspicious activity report narratives. Where NICE Actimize performs well, large and complex financial institutions, multi-channel fraud and financial crime programs, case management and investigation orchestration, suspicious activity report preparation, network visualization, governance and regulatory reporting, human-in-the-loop investigation workflows, legacy system integration. NICE reports that its investigation capabilities can reduce investigation time by up to 50% and suspicious activity report preparation time by up to 70%. Its Exceed Fraud Desk Copilot reports 80% faster alert triage and review, a 60% reduction in case-to-report processing time, and 40% fewer false positives. Benchmark assessment. NICE publishes strong operational and scale claims, but less public transaction-level precision and recall data. The buyer should request precision and recall by fraud typology, results before and after machine learning overlays, evaluated recall, false decline rates, investigation time by case complexity, auto disposition precision, performance under peak load. Best choice for large banks that need broad financial crime coverage, established governance, and deep regulatory reporting capabilities. Main risk, implementation complexity and the possibility that the most advanced capabilities require several modules and extensive integration work. Hawk best for explainable low-latency fraud and financial crime monitoring. Hawk focuses on explainable artificial intelligence, real-time transaction monitoring, fraud prevention, anti-money laundering, sanctions screening, and the convergence of fraud and financial crime operations. Its transaction fraud platform reports an average decision time of 150 milliseconds and supports automated clearinghouse, card, check, peer-to-peer, wire, and other payment rails. Hawk also promotes a hybrid approach in which traditional rules generate exceptions and machine learning evaluates the likelihood that an alert is a true or false positive. Where Hawk performs well: explainable machine learning, real-time payment interdiction, rules and machine learning in one workflow, fraud and anti-money laundering convergence, self-service rule management, model governance, deployment as software, as a service, private cloud or on-premise technology. Investigation automation. Hawk reports 3 to 5 times higher precision, 70% fewer false alerts, 30% more fraudulent customers identified, and a 62% reduction in anti-money laundering investigation time across its published impact materials. Its 2026 investigative agent extends Hawk beyond detection and alert prioritization into evidence gathering and investigation support. Benchmark assessment. Hawk's explainability and latency positioning are compelling, but a precision multiplier is difficult to evaluate without the original precision, population, test period, and intervention rate. Buyers should ask for the full precision recall curve and not only the claimed percentage improvement. Best choice for banks, payment companies, and financial institutions that prioritize explainability, rapid deployment, real-time interdiction, and flexible deployment. Main risk: confirm whether the investigative agent has sufficient fraud-specific capabilities or is primarily optimized for anti-money laundering investigations. Feature space: best for adaptive behavioral fraud detection. Feature space is differentiated by adaptive behavioral analytics and its automated deep behavioral networks. Rather than relying primarily on known bad indicators, the platform models normal behavior and identifies meaningful deviations. This approach is useful when fraudsters imitate legitimate activity or when the institution has limited confirmed fraud labels. FeatureSpace states that its models adapt to changing behavior and require less manual retraining, while analyst decisions feed back into future monitoring. Where FeatureSpace performs well: card fraud, account-to-account payments, authorized push payment scams, application fraud, synthetic identity, adaptive customer profiling, reducing model degradation, high-volume real-time transaction scoring. Public customer evidence is among the strongest for fraud capture. Central One reported 79% fraud capture volume, described as a 51% uplift over its industry benchmark, and 67% fraud capture value, while maintaining a 2-to-1 false positive ratio. NatWest reported a 135% improvement in the value of scams detected and a 75% reduction in false positives in one later case study summary. Earlier materials reported a 50% increase in detected fraud and scam value within 24 hours of deployment. QuanticsSpace also reports that TSYS scores 1 billion transactions per month and that 77.8% of challenged transactions were fraudulent in one 2025 case study. Benchmark assessment: FeatureSpace has strong public evidence for fraud value capture and adaptive behavior modeling, but less public evidence for autonomous investigation agents and remediation recommendations. Best choice for issuers, banks, processors, and payment providers where changing customer behavior and model degradation are major concerns. Main risk: make sure the platform's case management and investigation capabilities meet the same standard as its transaction scoring. Allow. Quantixa: best for graph-based entity resolution and contextual investigations. Quantixa is strongest when the fraud or financial crime signal is distributed across relationships rather than visible in one transaction. Its platform creates a connected view of customers and counterparties through entity resolution and graph generation. Contextual monitoring evaluates transactions alongside relationships, ownership structures, historical activity, and external information. QAssist supports investigation and report generation workflows. Where Quantixa performs well: entity resolution, counterparty and beneficial ownership analysis, money mule and laundering networks, complex investigations. Contextual anti-money laundering monitoring, graph-based risk prioritization, regulatory reporting, data unification across fragmented systems. Quantixa reports up to a 75% reduction in false positives, 50% or more reduction in investigative effort, and up to 40% of risks identified by Quantixa that were missed by legacy systems. Another public impact page reports up to an 80% reduction in investigation time at scale. Benchmark assessment: Quantixa is not usually the first choice for a sub-100 millisecond card authorization decision. Its value is often greater in contextual risk analysis, network discovery, and investigation acceleration. Graph-based methods can be highly effective, but buyers must test entity resolution precision, false links between unrelated customers, graph refresh frequency, multi-hop search latency, explainability of graph features, performance when relationship data is incomplete. Best choice for large banks and regulated institutions whose hardest cases involve hidden relationships, counterparties, mule networks, or fragmented data. Main risk: integration and data foundation work can be substantial before graph-based reasoning produces reliable results. NASDAQ, Verifin, best for consortium-powered community bank fraud operations. NASDAQ Verifin serves banks and credit unions with fraud detection, anti-money laundering, sanctions screening, high-risk customer management, information sharing, and investigation tools. NASDAQ reports that Verifin serves more than 2,750 North American financial institutions and uses consortium information based on data from thousands of institutions. In 2025 and 2026, NASDAQ introduced its agentic artificial intelligence workforce, including digital sanctions analysts, enhanced due diligence analysts, an agentic anti-money laundering analyst, and an agentic fraud analyst. The announced fraud analyst initially focuses on unusual automated clearinghouse activity. The platform supports recommendation mode, quality assurance, configurable human review, and planned auto-disposition of false positive alerts. Where Verafin performs well: community and regional financial institutions, consortium intelligence, automated clearinghouse, check, wire and deposit fraud, financial crime detection and reporting, entity research, information sharing among financial institutions, human-controlled agentic workflows, benchmark assessment. Verafin's consortium model is strategically important because a criminal may distribute activity across many institutions. However, public materials do not provide a standardized precision, recall, chargeback, or analyst time benchmark for the new agentic workers. Some capabilities were announced for phased rollout during the second half of 2026. Buyers should confirm exactly which workers, typologies, auto-disposition controls, and deployment options are generally available on the contract date. Best choice for North American banks and credit unions seeking a sector-specific platform with consortium intelligence and gradually expanding agentic automation. Main risk: the newest agentic functions are less mature than the underlying Verafin fraud and anti-money laundering platform. FICO platform, best for governed enterprise decisioning. FICO is best viewed as an enterprise decisioning and model governance platform with deep fraud capabilities, rather than as a single autonomous investigation agent. FICO's fraud portfolio includes real-time transaction scoring, fraud consortium models, adaptive behavioral analytics, strategy management, model development, optimization, and explainability. FICO has also highlighted temporal explanations that identify relevant past transactions, contributing to a decision. Its 2026 investor materials describe FICO platform as agentic by design, with explainable and auditable artificial intelligence, fraud consortium models trained on billions of transactions, and tools to build, test, optimize, and monitor decisioning. Where FICO performs well: large financial institutions with internal data science teams, controlled decision strategy development, model governance and lifecycle management, real-time fraud scoring, fraud consortium intelligence, enterprise-wide decision orchestration, explainable model deployment, integration with existing decision systems. FICO reports that its focused financial services models can produce more than a 35% lift in some transaction analytic models, including fraud detection. Valera reported an 85% reduction in fraud alert time and a 76% increase in cardholder self-service efficiency after deploying FICO platform capabilities. Best choice for large institutions that want extensive control over data, models, strategies, testing, and governance. Main risk: organizations may need substantial internal expertise to obtain the full value of the platform. Comparing graph-based reasoning with rules and machine learning. Rules-only systems. Strengths: highly explainable, fast and deterministic, easy to map to policy, useful for known typologies, simple to test and replay. Weaknesses: generate large volumes of false positives, can be bypassed by small behavior changes, require constant rule maintenance, often fail to identify new fraud patterns, struggle with cross-account relationships. Rules should remain part of the architecture because they provide guardrails and clear controls. They should not be the entire detection strategy. Rules and machine learning hybrids. Hybrid systems generally provide the best operational compromise. Rules handle hard constraints and known risks, while machine learning handles behavioral deviations, customer-specific patterns, peer group anomalies, risk ranking, false positive reduction, dynamic prioritization, emerging behavior. FeatureSpace, Hawk, FeedZai, Unit 21, Comply Advantage, FICO, and several other platforms use variations of this hybrid pattern. Hawk explicitly describes a two-stage process in which rules generate exceptions and machine learning assesses whether those exceptions are likely to be true or false positives. Graph-based reasoning. Graph methods are strongest when the evidence is distributed across entities and time. They can identify shared devices across accounts, reuse telephone numbers, common beneficiaries, fan-in and fan-out money movement, rapid pass-through behavior, coordinated merchant activity, synthetic identity clusters, mule networks, collusion. A graph model may improve recall for organized fraud while reducing the need to investigate isolated alerts. However, graph systems introduce additional requirements: high-quality entity resolution, frequent graph updates, relationship privacy controls, multi-hop latency management, protection against incorrect links, clear explanations of the path that produced the risk signal. A 2024 graph-based credit card fraud study reported precision of 0.82 and recall of 0.92, but those figures came from a specific research dataset and experimental setup. They should not be compared directly with vendor case studies or production chargeback rates. Agentic investigation. Agents are most valuable after a signal has been created. They can reduce the time spent on evidence gathering and narrative preparation, but they should not be treated as a replacement for a calibrated fraud model. The recommended architecture is synchronous rules and machine learning for the transaction decision, fast graph features for immediate relationship risk, asynchronous graph exploration for deeper investigation, an investigation agent for evidence gathering and case preparation, policy-controlled remediation, human approval for irreversible or high-value actions, explainability for regulator reviews. Explainable artificial intelligence can mean several different things. Buyers should distinguish among reason codes. Examples include unusual amount, new device, high velocity, or risky counterparty. Feature attribution. The system shows which variables contributed most to a score. Evidence-linked reasoning. The system connects the decision to actual transactions, devices, accounts, and external records. Policy reasoning. The system explains which rule, policy, threshold, or risk appetite setting was applied. Agent reasoning and tool history. The audit trail records which sources the agent consulted, what it retrieved, what it concluded, and what action it recommended. For a regulator, a natural language summary alone is not enough. The audit package should include transaction and customer data used at decision time, model version, rule and policy version, feature values, score and threshold, reason codes, graph relationships used, external data sources, agent prompts or task instructions, retrieved evidence, tool calls, human overrides, final action, timestamp, data lineage, changes made after the original decision, a reproducible replay procedure. The Federal Reserve's revised 2026 Model Risk Guidance emphasizes outcome analysis, ongoing monitoring, documentation, and validation of vendor products. It also states that institutions remain responsible for understanding vendor models, their limitations, development data, and performance. The guidance excludes generative and agentic models from its formal scope, but says organizations should still establish appropriate governance and controls for tools not covered by the guidance. The Payment Card Industry Security Standards Council similarly recommends logging and monitoring artificial intelligence actions, identifying a responsible human, and preserving enough information to audit prompts and reasoning processes where possible. A useful principle is, a plausible explanation is not proof that the decision was correct. Research published in 2026 argues that the quality of an investigation agent's rationale must be evaluated separately from the quality of its underlying fraud decision. Measuring fraud capture uplift against chargebacks. Fraud capture uplift and chargeback reduction are related but different. Fraud capture uplift. A useful measure is fraud capture uplift equals captured fraud after deployment minus captured fraud before deployment divided by captured fraud before deployment. This should be calculated separately for transaction count, fraud value, confirmed unauthorized fraud, authorized push payment scans, account takeover, card not present fraud, first-party fraud, synthetic identity, merchant fraud, money mule activity, chargeback rate. Chargeback rate should be calculated as number of chargebacks divided by settled transactions. Also measure chargeback value, chargeback basis points, representment success rate, customer dispute rate, fraud-related chargebacks versus service-related disputes, time from transaction to chargeback, chargeback recovery cost, customer complaints, false declines, approval rate. A platform can reduce chargebacks by declining more transactions, but that may damage revenue. Conversely, a platform may increase approvals while lowering fraud value through better targeting. The correct business metric is therefore not lowest chargeback rate. It is maximum fraud value prevented and recovered at an acceptable false decline, approval, customer friction, and operational cost. Latency at peak loads. Vendor latency claims are not directly comparable. A claim may refer to average latency, median latency, 95th percentile latency, 99th percentile latency, model-only latency, end-to-end latency, warm cache performance, a single payment rail, a test environment rather than production. Public examples include Unit 21 sub 250 millisecond decisioning claim, Hawks 150 millisecond average transaction fraud decision, Comply Advantages sub-second and more than 100 transactions per second claims, and NICE Actimizes millisecond level marketing language. A serious performance test should measure median latency, 95th percentile latency, 99th percentile latency, maximum sustainable throughput, peak burst throughput, cold start latency, dependency timeout behavior, queue growth, fail open and fail close behavior, latency by payment rail, latency with graph enrichment, latency with consortium lookups, latency during model updates, regional failover performance. The investigation agent should usually be outside the critical payment path. A payment should not wait for an open-source intelligence search, a large graph traversal, or a generative narrative. The transaction decision should complete quickly, while deeper investigation proceeds asynchronously. Data privacy and security. Fraud systems process highly sensitive information, including financial transactions, account relationships, device data, identity records, and behavioral patterns. In the United States, the Gramm-Leach-Bliley Act requires covered financial institutions to explain information sharing practices and safeguard sensitive customer information. The Federal Trade Commission's Safeguards Rule also places obligations on covered institutions and requires attention to service providers handling customer data. The General Data Protection Regulation places additional restrictions on decisions based solely on automated processing when those decisions have legal or similarly significant effects. It also requires suitable safeguards, including the right to human intervention in relevant circumstances. The Payment Card Industry Data Security Standard applies to entities that store, process, or transmit cardholder data. The Payment Card Industry Security Standards Council recommends tokenization, segmentation, encryption, access controls, logging, and responsible human oversight for artificial intelligence systems used in payment environments. Privacy questions to ask every vendor. Does customer data train a shared model? Can the customer opt out of model training? Is personally identifiable information removed or tokenized? Are payment card numbers replaced with tokens? Where is data stored and processed? Can data remain within a selected geographic region? Are consortium signals anonymized? Are raw customer records shared with other institutions? What is the retention period? Can data be deleted on contract termination? What subprocessors receive the data? Are large language model prompts retained? Can the investigation agent access external websites? Are agent tools restricted by role and policy? Are case records encrypted at rest and in transit? Can the institution audit every data access? Are private cloud or on-premise deployments available? FeedsEye describes a federated approach in which raw customer data remains local while anonymized signals are exchanged. Comply Advantage describes geographic segregation and enterprise security controls. Hawk advertises software as a service, private cloud, and on-premise deployment options. Unit 21's buyer guidance emphasizes data isolation, encryption, regional hosting, model training restrictions, feedback controls, and quality assurance. These are useful design choices, but none automatically proves legal compliance. The institution remains responsible for its data processing agreements, privacy notices, risk assessment, and third-party oversight. Model drift monitoring. Fraud is adversarial. Once a control becomes effective, criminals change devices, amounts, merchants, beneficiaries, payment timing, identity information, or transaction paths. A model monitoring program should track data drift, changes in transaction amounts, new merchant categories, new countries or regions, device and browser changes, missing or delayed fields, new payment rails, changes in customer mix, changes in counterparty mix, prediction drift, score distribution, alert volume, decline volume, review volume, auto disposition rate, threshold stability, calibration outcome drift, precision after labels mature, recall fraud value capture, chargeback rate, false declines, customer complaints, dispute outcomes, analyst overrides, suspicious activity report conversion, operational drift, investigation time, queue age, analyst touches per case, evidence retrieval failures, agent tool errors, hallucinated or unsupported claims, rule changes, model version changes, data source outages. The Federal Reserve's 2026 guidance recommends ongoing monitoring and outcome analysis to determine whether models remain accurate, fit for purpose, and reliable as products, customers, exposures, and market conditions change. Feature Space emphasizes adaptive behavioral models intended to reduce manual retraining. FeedsEye has published research on detecting streaming drift before labels are available. Unit 21 provides shadow, validation, and sandbox modes for testing new fraud logic. Comply Advantage provides rule performance metrics such as hit rates and false positive trends. Hawk promotes model lifecycle management and automatic model governance. A particularly important control is delayed label monitoring. Chargebacks and confirmed fraud labels may arrive weeks or months after the original decision. Organizations should not wait for final fraud labels before monitoring sudden changes in input distributions, alert patterns, or customer behavior. Recommended Buyer Scorecard. A practical evaluation can assign weights as follows. For the full table, please open this article on AIAgentStore.ai. Require each vendor to run the same evaluation. Provide a historical transaction sample with confirmed outcomes. Use a chronological rather than random test split. Run a silent production replay. Compare against the current rules and models. Measure precision at the actual review rate. Measure recall at the actual decline rate. Report fraud value captured. Report chargeback and false decline effects. Measure median, 95th percentile, and 99th percentile latency. Measure analyst minutes per alert and per case. Test peak traffic and dependency failure. Review explanations with fraud analysts and compliance officers. Test model drift across countries, products, merchants, and payment rails. Audit agent recommendations against source evidence. Keep high-value actions in human review mode during the pilot. Market gaps and a better solution to build. The largest market gap is not another fraud score. It is a standardized, evidence-native fraud operations platform that makes vendor claims measurable and regulatory reviews reproducible. A stronger solution would include the following: a two-speed architecture, sub-100 millisecond synchronous transaction decisioning, asynchronous graph expansion and investigation, separate agent environments for research and remediation, no large language model dependency in the payment authorization path, a universal evaluation harness. The platform should automatically calculate precision, recall, precision at fixed review rates, recall at fixed decline rates, fraud value capture, chargeback rate, false decline rate, approval rate, analyst time saved, case resolution time, 95th and 99th percentile latency, drift by segment and typology. This would allow institutions to compare vendors using the same definitions. Regulator replay packages. For every material decision, the system should preserve input data, model version, rule version, graph version, score, threshold, reason codes, evidence, agent actions, human overrides, final decision, reproducible replay instructions, privacy-preserving network intelligence. A future consortium should support federated learning, secure multi-party computation, tokenized identifiers, differential privacy where appropriate, regional processing, institution-controlled data retention, transparent consortium governance, safe remediation orchestration. Agents should recommend and execute actions according to configurable risk tiers. Low-risk false positives may be auto-closed. Medium-risk cases may require analyst approval. High-value payments may require dual approval. Account closures may require a human decision. Rule changes should require testing and version control. Regulatory filings should require accountable human sign-off. Evidence quality scoring. The system should score not only the fraud decision, but also the quality of the evidence supporting it. Are all claims linked to source records? Did the agent use stale information? Did it omit contradictory evidence? Did it confuse a related entity with the subject? Did it recommend an action outside policy? Can another investigator reproduce the conclusion? This would help prevent polished but unsupported investigation narratives. Conclusion: the best fraud detection and transaction monitoring agents are not simply chatbots attached to alert queues. They are layered risk systems that combine real-time rules, machine learning, behavioral analysis, graph intelligence, investigation automation, explainability, and controlled remediation. For most institutions, the strongest target architecture is rules for clear policy controls, machine learning for behavioral risk scoring, graph analysis for connected fraud and financial crime, investigation agents for evidence gathering, human approval for material actions, continuous monitoring for drift, latency, privacy, and outcome quality. Unit 21 and Sardine are particularly compelling for agentic fraud operations and digital financial services. FeedZai and FeatureSpace have strong evidence in large-scale payment fraud detection. Comply Advantage and NICE Actimize are strong choices for transaction monitoring, investigations, and regulatory reporting. Hawk stands out for explainable real-time decisioning. Quantexa is especially strong for graph-based contextual investigations. Nasdaq Verifin is well-positioned for consortium-powered North American financial crime operations. FICO is a strong option for institutions that want deep control over decisioning and model governance. The decisive buying criterion should not be the most impressive artificial intelligence demonstration. It should be whether the platform can demonstrate on the institution's own data and at production scale. Higher fraud recall. better precision, more fraud value captured, lower chargebacks without excessive declines, less analyst time, reliable peak load latency, defensible explanations, strong privacy controls, measurable resistance to model drift. All links to sources are available in the text version of this article. You can find the full article at AIAgentStore.ai, Agentic AI, and Workflow Automation. Thanks for listening. And thanks for rating the show. Visit AIAgentStore.ai to discover agents, tools, and setup files that help you work faster and automate more. You'll also find Claw-Earn, our job marketplace where AI agents and humans can both work and create tasks. Plus, marketing solutions for AI product founders. Explore it all at AIAgentStore.ai.